Happy Sunday. I'm going to show you in less than 3 minutes how to find the domain of a function. Today you're going to understand what is a domain, why it's so important to understand the domain of a function, and how easy it is to find the domain of a function. Let's do some math. The best way to understand what is the domain of a function, think about that friend that you can go out with her and then she's like, oh, everything I eat cannot have this, cannot have that. And then you have the other friend that is like a garbage can, and then let's say there's a he, it's like I can eat anything because nothing will happen to me. So this is basically what the domain of a function is. What values of x you can input into a function. So let's understand this. With that, you can understand that what the domain is going to be is the specific values of x that you can have for a function. So let me show you the most relevant functions we have in math, and then how to find their domain. You're going to be so surprised how easy it is to find the domain of a function. This website, by the way, I love it, QMath. Look at this, the different functions. You have the linear function, quadratic, cubic. Then here, this is the absolute value one, reciprocal, exponential, and so on. And each one is going to have a particular domain. So let me show you how to find the domain when you have a graph. Now, to find the domain using the graph, what I want you to do is just put your finger from left to right and think of having like a sensor. So here, the sensor is coming from negative infinitive all the way to positive infinitive. As you can see here, the same thing is happening here. It's like beep, 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 beep. Same thing here, same thing here. So the domain is basically like all the values that x can have. In this case, you can see that the domain of the four functions is all real numbers, because when I move my finger from left to right, basically you can see that I have x's in the negative and in the positive on the x values. Now notice that here you have a rational function. So when I go here with my finger, sensor goes on, and then when x is equals to 0, the x is not there anymore. That's what it jumps. That's what the domain of the function is going to be, negative infinitive to 0, not including it, from 0 to positive infinitive. Notice that the logarithm function and the square root function also has limitations, because look, nothing's happening here on the left, and then when I put my finger from left to right, my domain starts from 0, not included, all the way to the positive infinitive. And here 0 is included all the way to positive infinitive. So now let's do these functions algebraically. Let's do the most typical three cases. Case 1, you have the happy polynomials. These guys can eat anything, so they have no restrictions. Notice that you can have 0, negatives, any numbers you want here. That's what their domain is, from negative infinitive to infinitive, all real numbers. When you have rational functions, you have restrictions. Your denominator cannot be 0. That's why I grab my denominator, make the restriction cannot be equal to 0, solve, and then I just say, hey, I want all the numbers except negative 4. Finally, another example is the square root. And I put root, but it's root function, cannot be negative. So if I have the square root of x plus 3, since it cannot be negative, I put the restriction, and then I solve for x, and then I know that the values that this function can have of its domain from negative 3 to infinity. Obviously, there's more to understand about the domain, but this is the basic about how to find the domain of the most useful functions that we use in algebra, at least, when you're going to high school. So I hope you enjoy it, and have a good night.